Now example 6.9. A 3-meter long ladder weighing 20 kilogram leans on a frictionless wall. Its feet rest on the floor 1 meter from the wall as shown in the figure. Find the reaction forces of the wall and the floor. Now see, the situation is given to you in the figure. So here the length of the ladder, that is 3 meter, and it is placed 1 meter away from the wall at the floor. So this is 3 meter, this is 1 meter. So as per Pythagoras theorem, you can calculate BC, that will be 2 root 2 meter. And the weight of the ladder, that will be from its center D, and that is W as shown in the figure. Okay. Now see here, if we think about the forces which are acting in this particular situation, so here from D, the weight of the rod, that is in downward direction. Now reaction forces F1 and F2 are as shown in the figure. F1 will be perpendicular to the wall because the wall, that is frictionless. And here F2, that F2 we can resolve in two components. Floor, that is not frictionless, right? So here one component that can be represented as the friction along the floor, and it is not slipping, right? So impending motion, that is a slippery motion, but it is not slipping. So friction, that is in the opposite direction. So F is the friction, and another component that is represented as normal reaction. Okay. Now this one is in mechanical equilibrium. So first we consider the translational equilibrium. So for translational equilibrium, net force will be 0. Here the forces are in horizontal as well as in vertical directions. So we have to consider both the forces. So net force in horizontal direction, that will be also 0, as well as net force in vertical direction, that will be also 0. So first we consider the forces in vertical direction. So vertical normal reaction and W downward and upward. So N minus W equal to 0. Horizontal forces, friction and F1. So we can write F minus F1, that is equal to 0. Okay. Now consider the rotational equilibrium, and we have to consider this rotational equilibrium with respect to point A. So only two forces will give you the torque, W and F1. So we can write 2 root 2 F1, 2 root 2, that is the perpendicular distance of F1 from point A, minus half W, the perpendicular distance of weight W, that is 1 by 2 from point 8, because from the wall point A, that is at distance 1 meter. Okay. So here W, that is 20 kilogram. So 20 into 9.8, that will be 196.0 Newton. So 20 kilogram into G. Okay. Now from 1 you can write N equal to W, that is 196. W that we calculated here in first equation, we have N minus W, that is 0. So N equal to W. Now from 3, this equation, here if we substitute the value of W 196, then we will get F1, that is equal to W 1 upon 4 root 2, and finally you will get 34.6 Newton. Now in equation 2 we have f minus f1 equal to 0. So f, that is f1. So f1 we calculated. So f, that is the same one, 34.6. Now we have to calculate f2, right? f2 have two components, n and friction f, and these two components are perpendicular to each other. So we can write f2, that is under root f square plus n square, and if we substitute the value of f and n, and then if we solve it, we get 199 Newton. So the force F2 now here makes an angle alpha with the horizontal, suppose. Okay. So tan alpha, that is n by f, n by f, that will be equal to 4 root 2. Here directly we can write from this one, and alpha, that is tan inverse 4 root 2, that will be nearly equal to 80 degree. So here we calculated the magnitude and the direction of F2. Clear to all of you?